أول سؤال دكتور بس بخصوص question 7 بخصوص الإيكويشن تبع الفريكشن السم اوف فورسز ايكوال ام جي. أنت بالباوربوينت حاطة إنه هي الفورسز هن minus mg plus friction. شيء لازم يكون minus mg minus the friction.
All right, we're talking on the y-axis, right? And while talking on the y-axis, the mg, all right, it depends if you're moving up or down. So apparently I should be careful. As I'm moving up, I'm assuming friction is against me. All right, I can use this platform to draw. So this is your projectile motion, right? If I take the first part of the motion between A and B, I'm moving up and I'm assuming friction is down, opposite to me. So I'm assuming friction is down and mg is down. In this case, you take both to be downward. But if you're going down and assuming friction or air resistance is against you and mg is like this. So this is what I was assuming. And again, all that is related to some assumptions you can take. So this is what I was referring to. But now that you asked me, I'm thinking probably I should divide the thing into two parts. One part, assuming I'm moving up and then I'm moving down. But I cannot imagine you breaking down your motion into two parts and writing the equations of motions. Just pick any simple assumption. The point I believe behind this question is to see and to show that the acceleration will become mass dependent. In other words, you can pick any assumption. You can start by saying, I assume that the friction is along the x-axis, anything, all right? So it's opposite to the motion. Against mg, with mg, it doesn't really matter. You can take it absolute value and then replace f by negative f or positive f, okay? Don't do a lot of rigorous work because eventually we need to describe, like it's like descriptive qualitative approach. Although I know you're deriving the equation of motion. Okay, Anna?
ودكتور سؤال ثاني بس بخصوص انت ادينا تبلك الكينماتيك ايكويشنز الفريكشن انك تبلك الفي واي ايكوال 80 بلس في 0 واي ايكوال هاف 80 سكوير بلس all equations.
Okay, they want listen, the equation of motions are the x equation as a function of time and the y equation as a function of time. This is the equation of motion. If you want to write the v equation, it's also cool, but remember the v equation is nothing but the derivative of this one, so no need for any repetition. Equation of motion is the x as a function of t and y as a function of t, which is the half 80 squared plus v initial t, but make sure v initial is v0 cosine theta for x and v0 sine theta for y. And the acceleration is the x component of the acceleration or the y component of the acceleration. So no need to write all the kinematics equations. That's your phone, right? Okay.
بعدين في كم اسمه سؤال بس سؤالين صغار.
Can you ask Jane to mute herself? Is it Jane? Jane?
I think so.
Okay, I thought it was you, Imad. Jane, please mute yourself. All right, it happens. Yes, continue, Imad.
Yes, okay. السؤال الثالث هو دكتور بخصوص نحن فور اكزامبل اخذنا uncertainty فور اكزامبل خلينا ناخذ الرينج اخذناها 0.5 ملم بس لازم نحن الرينج الفاليوز فور اكزامبل اذا هي 360 نحط 360.0 لانه نحن بالكام 3 اخذين انه number of decimal points uncertainty لازم يكون نفس الشيء بالنمبر of decimals تبع الفاليوز.
Yes, that's true also in physics. So whatever values you have here, don't trust them. You have to round them. So if I gave you some random values that are not rounded, your job is to write 0.0 if needed.
Okay.
Okay. So yes, round those values. And from now on, I'm going to give you something. By the way, those measurements were done by students, if I'm not wrong, in spring 2019. So I did not do these measurements. And probably those students did a lot of errors and some mistakes, some, I don't know, but these are only measurements. Okay, which is great because I want you to see real behavior of the setup, not an ideal behavior. And real behavior would actually be visible if you have students taking measurements, or even your instructor, because it's a real setup. Okay?
Yes.
Yes, Imad.
ودكتور two small questions بخلص كل شيء. صار أخذت وقت كثير
No,
يوم.
no, أبدا, because I'm sure your friends would want to listen to these questions.
Yes. وهو سؤال الثاني بخصوص إنه اعتبر في عنا project emotion. الفي initial عنا إياها هي V0 sin theta for example. فيني آخذ الفي final تكون minus V0 sin theta due to symmetry.
All right. So you want to use symmetry yeah, you can use symmetry. But be careful. Make sure if symmetry really exists, and symmetry would exist basically if you have no air resistance. And I'm sure you know this.
Yes. Our question for
why not? Why not? Let's do that. Yeah, why not? I don't see why not.
واخر question دكتور بس بخصوص سألتينا انه واي انه واي is 45 هي عند على رينج. انا عملت انتويز بواي شرحت وبواي عملت بروف فين حط بيناتهم.
Yes, why not? So explain. If you have two methods to explain it, why not? I think it's interesting. All right. I'm gonna, if you're done, Imad, Christy is raising her hand.
Yes, merci.
But you can ask me again if you remember anything. Let me check the chat, Christy.
Of course.
Can we take F vector to be negative KV? Yes, Karel, you can do that, of course. Can we take any value for theta to draw the graph? You mean the sketch? Let me see. Are you talking about number 6? If you're talking about number 6, I'm expecting to see a sketch, and the sketch is actually just the shape of the curve. So I don't care about the plot and actual values, and I don't care to see an actual something. It's basically a sketch you can do with a pencil and a paper, okay? Take any angle, obviously. All right, so back to you. No. So when they say sketch, it's not a plot. I know that a lot of students would find it frustrating to sketch because they want everything to be computer-based. And I don't want you to experiment with new apps and stuff. Just do it with a pencil on a paper, take a scan of it, crop it well, insert in your document. I do that every day. I use my pen all the time with no problem. All right, so all right, so can we submit it now that we don't have any questions? Jane, a deadline means submit anytime before the deadline. You can submit last week if you want, anytime, okay? And let's say you remember something, you can submit again. I will only look at your final submit, like your most recent submission. All right. Friction on the x-axis is 0. It's up to you, Charles. Take any assumption you want and use it. But AX equals 0. This is if you have no friction, and you can take friction along X because, you know, just think of a resistance being in all directions. Okay, what else? Okay, are the velocities in the second table the same as those in the first table? Yes, I know what you mean. Since they call them V1, V2, V3, I'm assuming it's the same V1, V2, V3. That's why I did not write them again. Yes. Aya, what do you mean by no? But you need yeah.
Actually, doctor, I thought they were different.
Okay, that's all. But and then how would you calculate T1? You need V1, no?
Yes, exactly.
Yeah, all right. So yes, they are the same. I'm sorry if it was not clear. Basically, the gun or the shooting device gives you only 3 velocities and the same velocities for all the experiment. Like it's not, I can come up with other velocities. All right, if we take friction in both X and Y axis, I know that Christy is waiting. I'm sorry, Christy. If we take friction in both X and Y components, will take us a lot of time to find the equation of the trajectory. That's true, Karel. So take an easy example, an easy assumption and do it. Question A, is there really no pattern to conclude from? So the ended up to be an observation. All right, so number 7 and 8. Let me give you a hint. Do you understand? And by the way, this is very important. All right, this is where the motion is starting from. All right, here. And this is the ground. Okay, The height is constant. And the height is y, right? So point A will actually have the same y for all the cases, but not the same x, because some velocities will shoot farther. So I'm going to assume one of the velocities will shoot like this, one of the velocities will shoot like this, and this velocity will shoot like this. I have A1, A2, A3, all of which will have the same y. So you do understand that theta is equal to 0. Now, if you look at the projectile equation motions or the kinematics equations along x and y, you will find a very nice relationship between Vx and t. And probably you will find a constant somewhere. Remember, theta is equal to 0. Try to write the x equation again for x1, x2, and x3. You will find something interesting, probably. Yeah, maybe just specify what we mean by each, okay? Think of it again, all right? Probably this diagram would help you because a lot of students will not see that the starting point is the origin of the x and y. Now, please let me give some time for Christy, but keep writing on the chat if you need to. Yes, Christy.
دكتور عندي سؤال بالتيبل please إذا بترجعي.
Okay.
لا وين ما محطوط range s equals هيدا المحل الفاضي بدنا نجيب المين تبع each كل velocity يعني بدنا نجيب range المين تبعهم ونحطهم
No.
ولا بنتركها فاضية هيك؟
No, basically phi is a measured value, r is a measured value, and v is a measured value. So you're asking about the uncertainties, right? So to know the uncertainties for the, yeah?
Sorry, كفي.
Yeah, to know the uncertainties for phi, range, and V1, you'll need to look for the measuring tool. So this uncertainty is for one measurement. It's not the uncertainty over the averages, because you're not supposed to do the averages of those, because those are different measurements. It's not like the same trial happening all over. It's for different angles. And how do you want to find the average of those? These are different measurements. So this uncertainty is for each single measurement. And for you to know the uncertainty, you have to follow the rule. For a digital measuring tool, it's the smallest measurement. For an analog measuring tool, it's the smallest subdivision divided by 2. Now, how do you know which measuring tool we use? You have to watch the video again and look very well. I took some time discussing and explaining each measuring tool. For S, we used a ruler. Check the ruler again. For phi, we use the protractor, the big one attached to your gun or launching device. Check it again. And for the V1, we also used a timer. Check it again. Okay? So no need to do averages and ranges and RMS.
range بس ما هيك والانجل أكيد.
Say it again. Also V1.
Okay.
You know what? I still remember I gave you, let me see, answers for results. Do I still have them here? Look, I gave you 2.4.0 meter per second plus or minus how much? So
okay.
include like, probably you can create some space here or under V1, write a 2.40 meter per second plus or minus and write the uncertainty. And here you can see you need uncertainties for V1 as well.
Yes, okay. دكتور بس بعد عندي سؤال please إذا في أو
please beg
you.
I beg you to call me Jessie. Everyone.
ما في سوري ما بتطلع.
Miss Jessie.
Miss Jessie, okay.
Yes, Christy, you still have questions.
Question 5 please. هلا أنا مثلا إذا نقيت سكيل مثلا أوكي في أحط condition يعني تفسر يعني ليش نقيته يعني ما بعرف كيف بدي أقوله يعني suppose إنه نقيت A أوكي الB يمكن تزبط بس في condition إله.
Okay, فهمت
يعني
so what you mean is this is a multiple choice question, but you don't want to pick one answer. You want to write a paragraph about it and say probably 2 answers are possible. Usually in an exam, if you have a multiple choice question, you cannot do that. But since this is a lab report and you want the lab report to be open-ended answers, do that. Why not? But please don't do that if you have an exam and it's multiple choice, and you have one choice to pick. And I would definitely hear and read what you have to say. Okay? And probably
هون بعتبر إنه في condition مشان هيك يمكن تزبط بس مش always هيك قصدي.
Write it down. It's okay. يعني yes, I would say okay. Yes, it's acceptable. All right.
Okay.
Let me check the chat. Yeah, let me check the chats again. And please, everyone, I beg you to talk in English. Let's try this. So we don't calculate them. Yara, calculate them. Actually, you need to calculate, if you're talking about the same thing, T1, T2, T3, we need to calculate T1, T2, T3. It says calculate. And I remember underlining this because students would think they need to measure time. We need to calculate T1, and then you would notice something about T1, T2, and T3. Range, velocity, and phi should have the same dp. Dp, you mean uncertainty? Dp, delta p? What's dp, Jane?
Decimal places, doctor. Decimal places.
No, they're not related. They're not related. The range has a precision. Measuring tool is the ruler. Velocity has a precision. The measuring tool is the timer. Phi has a different precision. The measuring tool is the protractor. They don't have the same precision, okay, and therefore not the same decimal places. I guess she meant T1, T2, T3 are almost equal. I did not say that. Probably they're going to be equal, probably not. I would want to see how things would go on your side. So maybe the time remains constant. Yes, maybe, although they are not exactly equal, which might be because of some sort of error, probably. True, Aya, approximately 1 minute. Yeah, maybe try not to share a lot of answers, especially that some people have different results. So I don't want you to get confused. Just my own thought, Rab, it won't be wrong then. Do we calculate the error for who? For T1. I'm gonna get back to this. What's the smallest subdivision on the protractor? Don't answer, Andrew. Andrew, watch the video and you can tell. Okay. I'm happy I'm not glitching. Oh my God, Google is not working at all. All right, so Layla has a question, but before I listen to Layla, I need to say something concerning T1. You guys, T1, to calculate T1, obviously, it has to be something like X over V, if I'm not wrong. Am I wrong? No. So it's a function, like it's a calculated value, all right? Be careful what X and what V to take, so don't take me for granted, and no, I'm not trying to share answers. X has an uncertainty, and V has a different uncertainty. So to find the uncertainty on T, you need to do the propagation of error, okay? So you need to do derivative of this function, taken X to be your variable, then derivative of this function, taken V to be the variable, and then try to do it. If you cannot, talk to me privately so I can help you. Regarding 4D, what does draw a conclusion mean? It means try to find a trend or something obvious from the table. Where did we say draw a conclusion? 4D? Draw a conclusion. Examine the effect of launching the velocity. Probably you can see that the greater the velocity, the greater the range. Can you find any proportional relationship? Like double, triple, times 1.1 times 1.1. Come up with a conclusion, okay? If you don't like the wording, draw a conclusion, you can say deduce. Conclusion means from whatever you did previously. Did you see anything, a trend? And try not to say, again, I already told you this, try not to say increase, increase, decrease, decrease, okay? Back to you, Layla. Thank you for waiting. Yes, Layla.
Can I ask a question ما كتير خاصة باللاب report?
Of course you can ask.
Okay, فيك بليز ترجعي على الجراف اللي كنتي رسمتيها السمول 1.
Okay.
تحت بحس.
هيدي؟ No?
Wait, لا توصل. No, الجراف اللي نازل project على تحت.
Yes. The one with theta equals 0. Okay, I wish I clicked on the table of content. Okay.
Yes, can I annotate, please?
Of course you can.
Okay. هون, how do we know كيف بنلاقي ال Y max? It's a question, but كيف تلاقيها?
You mean Y max is actually the height, the maximum height. Oh,
Yes.
all right. So basically, all right, I see what you mean. You need this value, right? This value can be measured on your bench. And since you don't have access to the lab, you cannot measure it. Do you need it? It will not affect the values of your table. Because the table, remember that projectile motion is an X motion and a Y motion, and they're independent. Until you're studying the X distance and you're studying V initial. V initial is along X. So you can study only the X components and you can simply ignore everything related to the Y component, which means you don't need the height. But anyway, the only way to get the height is to go to the lab and measure the height of the gun, you know, the launching device. If you really want it, I think I have an old measurement of it and I can find it for us. But I know for a fact
that find it by calculation.
I can simply call I can simply call our lab supervisor and ask her to measure the height of the launching device.
But by just ask if we can find it by an equation.
We can try to do the calculations. Can we? Probably not, because we're measuring the point on the table and the table is at the same height of the launching point, which means we're taking that to be our zero. So no, our measurements even in the first table will not help us calculate the height. The only way to find the height of the launching device is to go and measure it with a ruler, and we can do that. But I know you don't need it for this experiment, but if you need it for a personal analysis, I can give it to you.
Okay, you wouldn't give us هيك شيء to measure, right? Unless we're doing the experiment no بإيدنا.
Okay, what do you mean I would give you something like in the exam?
Yes, and you wouldn't give us to find Y max on this.
All right, so these measurements will not help you find Y max.
Oh, okay. Thank you.
If you're thinking about the height, the actual height, like H maximum, whenever you have theta equals 0, you cannot use the, like, you know, the first equation when the first question where they said derive the equations for the height max. This height max would work only if you go from the launching to the ground, all right? Not like in this case where you have theta equals 0, okay?
Yes.
All right. That's your only question?
No, doctor, I asked you by email about number 6.
Yes, that's true. Let's stop the annotation so I can move to number 6. You asked me about number 6, right?
Yes.
Okay. Sketch on the same graph the trajectory of a projectile with a resistance, without a resistance. You will simply do this and this. You call this Y, you call this X, you use a pencil, and you do this for without a resistance. And with a resistance, you draw how it looks like. Now write the new equation of motion. You know for a fact that the net force will actually change. The net force was actually the force of gravity. Now you have force of gravity and friction. So you write net force equals MA. You find A for along X and A along Y, and you plug in A in the X equation. That's it. The X equation, if I need to remind you, it's half AT squared plus V initial T. A is the X component of A and V initial is the X component of V initial. So you can derive it. And I want you to try, and under no condition I'm expecting and myself to be harsh on you for this question. Like, I'm just planning to see how you start, how you end, analyzing your method, and I will not look on your final answer because I know it's not what I'm looking for. I'm just looking to see how you analyze stuff. Okay?
Okay,
so you will get a full grade anyway if you have an attempt of trying, unless it's empty or you did like a terrible mistake in it. All right, now let me go back to the chats. The derivative regarding correlation proportionalities, yes, you're talking about drawing conclusions. So when we fill the table, we get the errors from the measuring tools you used, and we don't write the averages for, no, Yara, be careful. We do averages only in one case, when you repeat the exact same thing under the same exact conditions. All right, so let's say you go on the bathroom scale and you measure your mass. and then you go again, and then you go again. Same clothes. It's not like you go have breakfast and come back. No, it has to be same conditions, you know? Otherwise, it doesn't make sense to do the average. We average the same repeated thing to increase precision. All right, no averages, just errors, rounding the values already in the table. Yeah, I wouldn't say rounding, but yes, rounding could be a good way to say it, but make sure you have enough significant figures for the measurement and for the uncertainty. Yes, now Priscilla and Imad. Priscilla, go ahead.
Doctor, I just wanted to ask that in the video, you said that the smallest subdivision for measuring the angle is 10 degrees.
I was wrong. But then I corrected it. Yes, I'm sorry. I remember
it should be 5 degrees, right?
Yes, I remember saying it wrong. Probably we can watch it together. I meant the smallest big subdivision, but then I said it again. And I'm sorry for the confusion. Which day was it? Day 3? Okay, let me open it. Let me show you what it is. But I'm impressed by you, Priscilla. Probably you are the only one who noticed this mistake. Well done.
I noticed in the table, the angles are 15 and 20 and 25. So I thought like the smallest subdivision couldn't be 10.
Yeah, you're totally right. All right, I'm glad many students noticed. I'm gonna try to zoom in. And let's make it final what the smallest subdivision is. All this is 45, right? Can I write on this guy? Yes. All this is 45. So I assume all this is 10 and this is 5. So and this is 5 in here. So what I meant is, what's wrong with my pen? So what I meant is this is 5. And no, I have no right to call it smallest subdivision. I mean the first block. So the smallest subdivision is 1 degree. So 1 degree is the smallest subdivision. Half of it is the uncertainty. So now we can be sure about it. Half the smallest subdivision. All right. Okay, Aya. All right. So yes, you want us to go to the first question Imad asked. Can you please, Aya, tell me what question you have?
Yes, of course. Doctor, you asked about mg minus f, okay? So if the movement is going upwards, right? The movement is upwards, okay? mg should be negative and f should be negative, right?
Yes.
Because they are both pulling the object downwards.
Yes.
Yeah, that's my question. That's
all right. And then I told you, listen, if you want to break down the motion into 2 parts, the up motion and the down motion, probably it's gonna be a lot on you to handle to write the equation of motion. So I said just take f randomly in one direction, and you can say later I can replace f by positive f or negative f, you know. So let's not complicate things and make them so precise. All right, because if you really think about it, friction is a real example. And no matter what you do, eventually what you're doing is an assumption. An assumption is to assume something or create a model. And none of the models you will pick is exactly real. So whatever you do, even if you have the best model, I think the best way to describe projectile motion with actual friction is to create a computer code who can do the whole thing. Because you know friction is not a constant anyway, and it's a very complex thing. So don't try to seek accuracy and precision because you cannot. So it's only a simple question to describe things and just to see if I take it a bit like one step closer to friction, what would happen. All right?
Okay, but is it wrong if I did that because I already finished my report?
No.
Okay,
I would be okay with it. Priscilla, I forgot to ask you, are you done with your questions?
Yes, thank you, Doctor.
All right, Imad, do you still have questions?
Yeah, Doctor, 2 small questions. بس أول شيء البروباجيشن أبقى أنا دكتور تحت إنه بس نعمل derivative، رولي نعمل derivative of cosine هو في cosine theta أو بناخدها نتذكر إنه cosine 0 1.
هلا since cosine theta equals to 0, you can simply say V initial along x is actually equal to V initial. And there's no theta in here. It's not like theta is variable and you replace it by 0. No, in the whole problem starting number 7, theta is not there. So no need to do the derivative with theta. All right?
Okay, doctor.
Okay, do you think we can start lab 2? Because we took like 32 minutes only for lab 1, which is good. And I still believe some of you may have some questions still. Do you want to see the derivatives? It's up to you, actually. We want you to explain briefly what you do. If it's a lot on you to show us, Ellie, you can skip this part, okay? Yeah, but if you believe you can show me a bit of it, or at least the first equation and the final answer, it's gonna help a lot, okay? So if you still have questions, please feel free to ask anyway, anywhere, I don't know. Do we have to find friction on both x and y axis? You mean to answer number 6. It's up to you to take any assumption you want, Taimad. Okay? So you can say, I assume friction is along the y-axis and answer the question. It's a model eventually, okay? Probably in the next semester, I would write this question differently and probably start by pick your own model, pick your own assumptions and do that. Or probably I pick for you before you do it. I will say, assume friction is like this, derive the equations. Yes, my bad. But remember, a lab report is an open-ended questions. And I know you're not used to this because coming from high school, there's always one answer to the questions and nobody likes this, right? It's always good if we give you some room to think a bit outside the box. And you mean that no need to do x of t? No, write it down to show that it's gonna change or not. It's okay. All right, now back to our plan. Yes.
ما فهمت علي. ما أنا إذا أنا لقيت على الواي أكسس فكيف إذا عملها ريبليس بالأكس أكسس ما فينا أعملها ريبليس بالأكس أكسس.
Okay.
أنا هذا قصدي إن أنا I took.
So I'm sorry, my screen is frozen. Okay. You write the x equation and you write the y equation. The x equation is not gonna change, and you say it that it's not gonna change. The y equation is the only one that is gonna change. All right?
Okay, merci كتير.
All right, assume on both components. Okay, fine. I wrote it by hand. All right, I always get questions like these. Students doing a lot of calculations by hand and they don't want to type them. Your lab report has to be typed. If you want to scan your equations and you know this is exceptional, and yes, do it, because I do understand that the deadline is very soon, but please keep in mind in the coming weeks, everything has to be typed, okay? Probably in the calculation you did on paper, Karel, you explained a lot. Probably you can type 5 steps out of your 10 steps. I don't know. Find a way for the future. And if it's exceptional, it's okay. All right? Okay. Now back to this. And I don't know why I cannot click on this window. Yes, I can. There's something wrong happening. I cannot move my windows. Why? Everything is frozen. Okay, probably if I stop recording, can you hear me?
Yes, I can.
Okay, just a second. I don't know what's wrong. Okay, I'm gonna stop recording for a second. All right, back to this one. I know that we still have to do a lot of data analysis. We did data analysis number 1, which deals with one measurement, averages, and propagation of error. We never had the chance to discuss linear graphs, and we did not have the chance to discuss error on the slope, and this is really important. Today, we took a lot of time discussing this one, and we don't need this one yet, so probably I can postpone it until I don't know when, but I'm not gonna forget this part, it's very important. I need to start with lab 2. It's an easy lab. The lab report is also easy. However, we have some data analysis to do. You have a lot of propagation of errors to calculate. They are a bit tough, so I'm gonna give you some hints. And you have averages to do. And you need to discuss acceleration along the incline. So the physics behind it is also very important, okay? So let me start by opening the PowerPoint, the slides. Okay. And probably put this away and this away a bit. So what we have, the outline, you see we have a lot of stuff in the outline, but basically simple stuff. I'm gonna start with the force diagram. I need people to help me and probably get back to my, which window is it? This window, and fetch your names, which is already ready. Just let me pick the class. Yeah. So happy with my internet connection. I couldn't do any of that few hours ago. It's weird. Okay. If it doesn't sign in, it does. All right, I'm just gonna click on your names and start immediately. I'm not gonna waste time. Users. Okay, I'm gonna ask Nuha, first name. Yes, Nuha, back to you. So, Nuha, my question is actually very simple. Can you please help me divide how many forces I have on my crate, sliding down an incline, and just assume that you have no friction on your crate.
Okay, we have the normal force and
okay. So I'm gonna draw all the forces from the center, although that's an approximation. I know in some books the forces are not from the center. So again, that's an approximation. This is the normal reaction. Yes. Any other force?
Yes, it's always perpendicular to the surface.
Yes, that's so true. Any other force?
And weight, it's vertical downwards.
Okay, the weight, I usually call it mg, just to keep it as a reminder. Thank you so much, Noha. All right, now I'm gonna look at this diagram.
Thank you.
Yes, and probably try to draw these again. I want to find the net force. To make your life so much easier, I'm gonna take the normal again. I'm gonna call it n, and I want to break down the mg vector into mg sin and mg cos. So this is mg sin. Okay, let me write it a bit far. So this is mg sin, and this is mg cos. I know all students back in high school should know how we break down the mg vector. Probably a lot of students know that it is mg sin and mg cos, but probably they cannot remember why. All right, if you want, we can prove it very quickly. This is your mg, and it's basically the resultant of these two. So you can see my drawing is not very accurate. This is theta, and this is also theta. And the x component is opposite to this theta. That's why it's mg sin. The y component is this one, which is adjacent to theta, which is the mg cos. But anyway, all students around the world, they don't think of SOHCAHTOA and cosine and sine and opposite. They just know that the component along the incline is mg sin. So in other words, I'm trying to tell you, I want you to know this and not think about it always, okay? So by looking at this graph, you would see that the n will cancel out with the mg cos, and you will end up with mg sin, though this is your net force. So I'm going to write my net force to be equal to ma, and this is Newton's second law. Actually, no, I'm going to do this in the next slide. So now that we wrote the forces well and nice, I'm going to move to the next slide to write the following. Now that I have net force equals ma, I need to remind you that this is in bold. It means it is a vector. You know, in some books, bold means vector. Instead of f, since I don't have any normal, mg cos and normal will cancel out, I simply have mg sin, and it is along the motion. So I'm going to replace this with mg sin. Pick another color, probably green, a bit thicker. Yeah, so mg sin. Green is awful, I'm sorry. Let's live with it. Theta to be equal to ma. Okay, m and m will cancel out. We're lucky we have no friction. Otherwise, friction will not let us cancel out the m, exactly like in projectile motion. And we end up with acceleration to be g sine theta. Also, a lot of students around the world, they know this as a fact and they don't prove it and derive it all the time, although you are responsible to know how I got the acceleration. So from now on, we know for acceleration for free fall is g. Acceleration for an incline is g sine theta. Your name, Andrew, is Andrew. You don't think about it. It's a fact. So people know for free fall, A is G, and G is downward, acceleration is vertical down. For an incline, it's G sine theta, and the acceleration is down along the incline. So these are like facts we know, although we can prove them, okay? And again, this is only if you have no friction. Now the experimental setup, and you will see it on the video, okay? What's wrong, Imad? Did I say something?
لا كان قصدي دكتور انه انا هيدي البروف ده بعد بستخدم كوساين كان دايما نضيع فيها فعلا.
Okay, so
فاذا فيك احنا في سيشن يعني.
ايه لك منا صعبة. I can show it to you. I can show it to you now. Look, it looks difficult, but it's not. So this is your MG, okay? This is your MG. I'm gonna draw the X and Y axis. This is the Y axis, and this is the X axis, okay? This is theta, which is equivalent to this. Now I'm gonna draw in blue, hopefully blue is thick enough. I'm gonna draw this to be the X. I'm gonna label it X, and this to be the Y. I'm gonna label it Y. Okay, now go back to SOHCAHTOA. So and Ka. I'm not gonna do TOA because I don't need the tangent. All right, so states that sine is opposite over hypotenuse. So sine the angle is opposite, which is X over hypotenuse. So sine theta is X over mg. So X is mg sine theta. That's why the X-axis, which is here, is mg sine theta and mg cosine theta. I remember I always tell my high school students, you always know that the X component of any force is force cosine theta, and the Y component is always force sine theta. And the inclined plane is the opposite because theta given to you is along the Y. It's theta of the incline and not theta of the force itself. All right? So if you still believe that this is difficult for you to know, simply know them. But the derivation is not something difficult. It's basically looking at this right angle triangle and using the SOHCAHTOA, or the fact that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. All right? So when should we expect the results? What do you mean by results of this experiment? The results of this, yeah, usually every time I see you, it will be Monday, and every time in the evening I post the results. All right? Unless I have an emergency or something happens, yes. All right, and every time I post the results, I send you an announcement because I know some of the students may be waiting for that. All right, so now the experiment, you have a cart. So this is basically an inclined plane. I remember using some leveling to increase one side of the inclined plane. The inclined plane is very smooth. I wish you can touch it. It's made of aluminum. It's a bit heavy, although it's aluminum, it's thick, it's very smooth, and the cart has the perfect wheels ever. I wish you can play with the cart. It's like so fast, it goes so fast. We have a bumper, otherwise the cart is gonna fall on the floor, and you have a motion sensor. The motion sensor is the easiest sensor to be around with. It doesn't need any calibration, it doesn't need zeroing, it's user-friendly. What does it do? This is how it looks like. All right, and it's explained basically on the video. I will show it to you in the video. It sends some ultrasounds, and you know ultrasounds, you cannot hear them, but it has some tick, 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 tick mechanism because you need to know if it's functioning or not. So the tick, 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 tick are not the ultrasounds. So it sends ultrasounds, and those ultrasounds will go out of the motion sensor and will hit the obstacle. And you know, reflection will happen, and the motion sensor is gonna be receiving the ultrasounds again. So it is an emitter and a receptor, okay? The motion sensor is connected to your computer, to a special hardware device called a it's called the Science Workshop, and Science Workshop will work following an application, a special application called Data Studio, which is also user-friendly, and probably some of you saw that in high school. So the motion sensor can tell the time taken by the wave, the ultrasound, to go hit the obstacle and come back like regular echoes. Also, we can simply put in the setup of Data Studio the speed of sound, which is also an approximation, and it can hold some sources of errors because If we are in a humid environment, too hot, too cold, probably the speed of sound is gonna change. So we're assuming the speed of sound is something. Knowing the speed, knowing the time, you can tell the distance. So the motion sensor indirectly can tell the position of the cart, okay? And you know, position could change as a function of time. So the software can calculate the velocity instantaneously. Also, the velocity can change as a function of time. So the software can calculate the instantaneous acceleration. So every time you have a motion sensor, expect to measure so easily an XT graph, a VT graph, and an AT graph. So if you want a VT graph of the obstacle, I will call them motion graphs. And an AT graph, you can simply use a motion sensor. So this is what it gives you. It doesn't measure mass, it doesn't measure temperature, it doesn't measure force, only positional motion graphs, okay? Very nice. We're gonna use this sensor in most of the experiments. Now this, the same experiment. Actually, I'm sorry. Yes, let me move this to the side. This is what you will get. You will see that as the cart is getting away from the motion sensor, x0 is how far away you are from the motion sensor. That's the initial position. And it's gonna get far and far and far while speeding up. You will see that the speed, it's gonna start from 0. So this could be measured not at time 0. The speed is gonna increase in a linear way. So the speed is going to increase in a linear way. The position is going to increase in a non-linear way. And you see the acceleration is constant, which is obvious. I need to remind you, for an incline, acceleration is g sine theta. Since g is a constant, we're not moving around planet Earth, neither around the universe. G is constant. Theta is constant because I want to make sure our track is not going to move a bit. Actually, I want to put my track on a very like a wall or something, because I don't want it to slide every time the cart will hit the bumper, okay? By the way, I have a protractor attached to my track to keep on measuring the angle all the time, make sure it's a constant. This would help you see why velocity is constant. You will, increasing in a constant way. Since A is g sine theta and A is constant, this is the linear relationship. It shows that V is gonna increase in a linear way. By the way, the downward motion is taken to be the positive direction. We can take it negative if you want, but in this software, they took it to be positive. That's why the acceleration is positive. You can simply change it to negative and no problem will be involved. If you look at the X equation, you will see it is a function of t squared, and that's why you have this polynomial or curve or whatever you want to call it. So V is a function of t, you get a straight line. X is a function of t squared, you get a curve. And A is a constant, that's why you get a straight line. So this is theoretical. In fact, I'm not gonna do this. I'm gonna do something like that, and let me explain. I'm gonna push my cart upward. The cart is gonna travel up the incline, slowing down to a stop, and then come back down to the bumper. It's gonna collide and come back again up, then go down, collide. So this is how I will do the experiment. I'm gonna push it up. If you want, I can push it down. So if you ever see this, I don't want you to be confused. What does it mean? It means that the cart is going away from the motion sensor and it hits the obstacle, collision. So what you have here is a collision. It's a sudden change in the direction of motion due to the collision with the obstacle. So you get closer to the motion sensor, then away, and then another collision, closer, away, collision, closer, away. And you see the energy is getting less and less because you're losing speed after every collision. It's not an elastic collision. So eventually the cart is gonna stop. Here you see speeding up down the incline, then collision. You see this sharp change? It is collision. And then slowing down to a stop. So this is a stop for a fraction of a second, then speeding up again. All right? Is that confusing? Then what you want, you need, okay, this is a screenshot of the video. It doesn't look good. I left the thing colliding many times. I wanted to show you going away from the motion sensor, collision, closer away, collision, closer away, collision, closer away, collision, closer away. And then you cannot get very close anymore because you're stuck to the bumper because of the many collisions. Speeding up, collision, slowing down, speeding up, collision, slowing down, speeding up, collision. As you slow down, this is the zero axis. So you stop for a fraction of a second to turn back down. All right, and here you see constant acceleration, then collision, constant acceleration, then collision, constant acceleration. And here you have a lot of errors. Can you see the errors? So if I were you, I will not focus on the first motions because of the many errors you have. All right, so now what you're supposed to do? You know that theoretically, which is here, A is G sine theta. This is theoretically. Now experimentally, you're supposed to find the acceleration. How do you find it? You're gonna select this part and ask your data studio to find you the slope. And the slope is gonna be the slope calculated, like the average slope calculated by data studio. Because you have some errors in here and data studio can find the average slope. Also, if you want, yes, data studio is the software you're working on the computer with. So this is a screenshot on the computer screen. You will see it now on the video, and I can select, and probably I will show you on the video how to select. Click slope, it will give you the slope. Okay, the slope in a VT graph, and let me show it clearly. This is a V versus T graph, and this is an X versus T graph. Okay, the slope in a VT graph is the actual acceleration. So this is how you find the acceleration experimentally. Now they will ask you to compare, and this is very important. Probably you know how to do it. Every time they ask you to compare two values, what you do is the following values. You will find the percentage difference. You don't say this is bigger than this and this is smaller than this. You do the theoretical value minus the experimental value, and you divide by the theoretical value and you multiply by 100. So you compare the difference with the theoretical value. For example, if the difference is 1 and the theoretical value is 2, 1 is a lot with respect to 2. It's like 50% error. And if the percentage difference is, so if below 5%, I'm gonna say accurate. Accurate means close to the theory. But please do not expect to get 5% and below. We know our setups, we know our measuring tools. So if you are above, let me say below, all right, I'm gonna say expect measurements to give you a percentage error, to give you a percentage difference to be around, equal around 20%. Okay, and I'm sorry for that. Remember, these are real experiments. We're assuming no friction, and we do have. We're assuming, I don't know, normal temperature, and probably we do not have. We have the motion sensor. It's a measuring tool, and it doesn't have unlimited precision. Probably, what else am I using? So think of the different errors, and probably I should send you a list of errors to think of, to check, you know? All right, so if you get 20% error, don't freak out. You can get 5, 6, but anything above 5, you can say not accurate, okay? What else? Before I discuss friction, which is our next thing on the outline, let me show you the outline for you to see where we're at. We did force diagrams. Where's my pen? Force diagrams, Newton's second law, experimental setup, motion graphs. How do we measure the acceleration experimentally, which is the slope in a VT graph? Let me skip this one for a second and show you the lab report now that I told you that how we do the experimental. Let me see the questions. Data Studio, no, you don't install it. You actually use it in the lab to take the measurements. And since I'm gonna give you the measurements, I'm gonna use it. I'm sorry for that. Okay. You should compare A experimental to A theoretical. So you will calculate A theoretical being G sine theta. Let's say it's equal to 3 meters per second squared. You do the experiment, you get 2 meters per second squared. You compare them. Okay. I'm gonna show you the lab report. Yes, I know, Eli. Eli, let me tell you what you're missing out. Those experiments are my favorite experiments, and I feel so bad for you. Okay. All right. You want to touch the aluminum. All right. I hope by the end of the semester we can have a session or two for you to touch those equipment. All right. I'm so sorry for that, but you know, safety, your safety now is very important, and it's okay. It's not the end of the world. Probably, I don't know what to say actually. Let me show you the lab reports a bit. Mass of the quartz, where do you get it from? Watch the video. I will show you in the video the mass of the quartz. And I will tell you orally in the video if I did the measurement using a measuring tool that is digital or analog for you to know the plus or minus. All right? The angle will be given to you. The uncertainty, check in the video for the smallest subdivision, digital or analog. Here you put the unit, obviously meter per second squared. The trials, I did the same exact measurement, like repeating, releasing the card 5 times, and I got the same graph, found the slope, found the slope, find the slope, 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 find the average, so easy, you add them up. Now, what is the error on the average? Probably I can ask Rhea. I've never talked to Rhea before. Rhea, how do you find the error on an average?
We can consider it addition when you're adding the value.
Okay, and then use the equation given by the chemistry lab.
My PHY lab, what did you say?
Yeah, how do you find the uncertainty on the average?
I usually use the formulas from the chemistry.
Okay, but it's an average. So you may want to do standard deviation or something. So please use the RMS error. I'm going to write it for you, RMS error. How do you do the RMS error? Go back to your Blackboard, check data analysis 0. I give you a method, which is the calculation method, and another method, which is the calculator method. Pick any method you want. It's important for you to learn this today, okay? Because you will not be given a lot of lab reports where you have RMS. So this is your chance to practice before the midterm. And let me know if you need help, Rhea or anyone else. All right. Now to find a theoretical, you're going to do... Yes, Rhea. Yes, it's alpha RMS. All right. So to find... You're glitching, Rhea. If you're saying something... Standard deviation, no. Rhea, please type in the chat. I cannot hear you. At least standard deviation divided by radical n. Yes, that's true. All right, so to find a theoretical, you simply need to do G sine theta, and theta is given here. So G will be given to you, but it's going to be 9.81 meter per second squared. And let me write the error as well, because you may need it. Now they want you to calculate the error on the acceleration, which is the theoretical acceleration. So you're going to say A is G sine theta, okay? And you're going to do the derivative with respect to G, and then the derivative with respect to theta. Yes. And if you need help, you will let me know. Let me know how it will go. All right. Theta is given with the error on it. G will be given with the error on it. Do the calculations. You're stuck, you let me know. Okay. I'm going to change the angle again and change the angle again. Okay. Yes, it's okay, Rhea. Let me know if I can help with any way. So here they ask you to compare your experimental to the theoretical. Comment on the sources of errors. It means give at least 3 sources of errors. And then they ask you to deduce the effect of increasing the angle on the acceleration. Think about it. And then they add a mass. They tell you what is the extra mass, and they give you the different acceleration. So, and then they want you to deduce the effect on the mass, effect of adding a mass. If you add a mass, will the acceleration change or not? Check your measurements and discuss it. Okay? Here, they want you to devise a procedure. Okay, here, what do they mean by devise a procedure? That could verify this. Think of an experiment and say, to be able to measure this, I would want to try this experiment. I would need those equipment, and this is a picture of the setup. Okay, so this is a thought experiment. Devise mean create an experiment of your own. Okay, because this experiment will give you a special relationship between the acceleration and the mass, and here they want a different relationship. Can you come up with a procedure, like briefly say what material are needed, and a picture of the setup? Do you want it an incline? Do you want a pulley? Do you want a horizontal track? And so on. And show me, derive the equation to show me the inverse proportionality of whatever. I'm trying not to give you hints. All right, now I'm ready to go back to friction. Friction. I don't know if you did the Lebanese curriculum, probably you've never discussed this before. Only IB and American high school know a bit about it, okay? I'm not gonna make a big deal out of it though. I know in the course you need to discuss this. So this is a box on a horizontal floor, and you see the floor is not smooth. I'm gonna push the box in this direction. There's friction against me, okay? The object is not gonna move. I'm gonna keep on pushing stronger. Friction is gonna be stronger. Equal and opposite, the object is not gonna move. I'm gonna keep on pushing stronger and stronger. Friction increases. If I push with 20 newtons, friction is gonna be 20 newtons. If I push with 40 newtons, friction is gonna be 40 newtons. Until friction cannot take it anymore. This is where the object starts moving. And I still have friction on it, but it's gonna be a bit lower. Okay, so this is the threshold of motion, or the peak at which motion is gonna happen. I'm gonna call this case, probably this case here, static friction, because friction is on an object that is not moving. And the other part of the graph here in pink, it's gonna be kinetic friction, or because the object is actually moving. And you can see you have a coefficient of static friction that is 0.5, and this is a coefficient of kinetic friction that is 0.4. So friction is a bit less whenever the object starts moving. Whenever the object is not moving, friction can go to a very high value. Static friction, kinetic friction. Static means object not moving, kinetic means object is moving. Let me talk about the coefficient for a moment, okay? The coefficient of friction is related to both surfaces. Probably if you can see my camera, you would see that you see my phone, you see the cover of my phone. It has a very high friction. This is horizontal and the phone is not moving. If I actually create a certain incline, the phone is not gonna slide. And this incline at a greater angle, the phone is not gonna slide. And this is due to static friction. The coefficient of static friction here is related to the rubber you have here and the skin that I have here. So my wet skin and the rubber of the cover, both will give me a certain static coefficient. So you see static friction is related to both surfaces, rubber on dry concrete, rubber on wet concrete. So it's gonna be different. Wood on wood, like wood on wet snow, and so on. You see, all of them are below 1. Although I saw somewhere that it can go a bit above 1. It's a coefficient with no unit, all right? For kinetic friction, you see it's always smaller than static. Whenever the object starts moving, it's gonna be a bit smaller, okay? And all these have no units. Now, how can I apply this coefficient to my calculations? Basically, friction is equal to mu times the normal force. You know, the normal force and friction are not in the same direction. So this is a magnitude equation. So the magnitude of friction is equal to mu times the magnitude of the normal. Let me show you again. This is the normal, right? I have mg also, which I'm gonna break into 2 components. This is mg cos, right? And this is mg sin. The object is sliding down, so I have friction in here, even if it's tiny. To know how much friction is, I say friction is actually equal to the coefficient mu let's say this is sliding, or let's say it's at rest. So if it's at rest, I'm gonna increase the vector F to be equal to mg sin. I'm gonna say mu static times normal. Now, how do I find the normal? Fadi, can you help me? In this case, can you tell me what the normal is?
The normal is negative mg cosine theta.
All right, the normal in magnitude is equivalent to mg cos theta. So I'm gonna replace this by mg cos theta. Stay with me, Fadi. If I have no motion, can you tell me how strong friction is?
If we have no motion?
Yeah, equilibrium in other words. Can I say it's equivalent to mg?
It's mg sin theta.
Okay, so it's gonna be equal to mg sin theta only if we're discussing no motion. So let me say no motion because my diagram is confusing. You see mg sin theta much bigger than friction. Let me assume I'm still static in the static case, all right? So mg and mg will cancel out and you will end up with mu static to be equal to sine over cosine, which is tangent theta, okay? So this is a fact, and it's a very nice experiment, by the way. How do you find mu of static friction? And you can apply this to my phone. You can put my phone with the cover, obviously, on a book, and you start increasing the angle. You start increasing the angle. You start increasing the angle until you reach the threshold. And the threshold is this peak, okay? Until you reach the threshold or the angle at which it's gonna start sliding. You stop immediately when you measure this angle. You do tangent angle, you find mu s. Okay, and this is the experiment you're gonna do. So this is the table you're gonna fill. I'm gonna give you a box. It has two surfaces. From one side, it's wooden. From the other side, it's like a fur, something like a very thick textile. And you're gonna put it, these are 5 trials, by the way, the same exact measurement happening again and again. And I'm gonna increase the angle of the incline, all right? So I'm gonna increase the angle of the incline until it reaches a certain value, until it starts moving. Whenever it starts moving, I'm gonna give you the value, 17 degrees, for example, or 18 degrees. This is the angle at which the thing starts moving. You find the average for all the thetas by doing average. You find the error by doing the RMS. You repeat for the textile surface, and then you find mu s by stating tangent theta. Very easy. But since mu s is equal to tangent theta, to find the error on mu s, you have to do the propagation of error, and therefore the derivative of tangent theta. Try to Google it. I'm sure you forgot what the derivative is. All right, so Priscilla is crying because of tangent theta. Yes, everything is recording and it's still recording. The lab report is long, probably. Is it much harder? Yes. How about I take a quick look at lab report number 3 to see if it's even harder or not. If it's not, probably it's good for you to know. I can't remember because I did not teach Physics 302 last semester, so I forgot. Not scary, you have a week. Oh, this is open already. You have a week and I can help you. Centripetal force. All right, let me tell you that centripetal force, the physics is more difficult, but the lab report is easier. However, for centripetal force, you need to do a lot of linear regression and error on the slope. And since we did not cover this yet, next week, we have no choice. We have to do linear regression, which is data analysis part 2, before we proceed. All right. Yes, momentum and collision is gonna be regular. Okay. So Ellie is on the threshold of pain. All right, I'm sorry, you guys, listen. How about you try your best and we see how things will be? Okay. My computer is frozen again.
Yes.
Hello.
All right, so I can see you. Am I back? What happened?
Can you hear me, doctor?
Yes, I can hear you. Can you hear me?
You never left.
Okay. Yes, now we can hear you. Before you couldn't hear us.
Yeah, I got disconnected. Can disconnect. No, don't worry. Zoom is still recording. Don't worry. The recordings are always saved. Zoom is the best. Don't worry at all. And even if we get disconnected, it's gonna pause for a second. Okay, so basically, yes. No, I think my internet connection is not okay today. So I was saying that I can feel you guys are anxious. How about you start with the lab report and let me help you, okay? So forget that I'm the one grading you for the moment. By the way, we still have one slide that it says we have the video. How about we take a few minutes to watch the video? You want? Not really on play, but on fast forward. So for you to see the equipment, no? Yes, what do you suggest, Aya?
Yes, good idea.
دكتور كنا بنقول على الشات إنه بحس حياخد more than 1 week. And we have a lot of exams. هلا عندنا chemistry exam. To be honest, it's not easy at all. So maybe can we please extend the deadline?
So let's say I give you 1 extra day. Do you think your life is gonna be beautiful like that? Probably it's gonna be worse. And then you will have the next one. Listen, if it makes you feel better and it makes you perform better, I don't see why not. All right?
All right, okay.
Okay, so for the deadline, I'm gonna give you 1 extra day. Is that what you want?
All right. Thank you, doctor.
Instead of Monday evening, it's gonna be Tuesday evening. All right? Yeah, but again, don't forget that postponing is sometimes not a good idea. I'm gonna go fast forward on the video to show you a bit the equipment. I took this video probably in October. What are we? February? Not long time ago, but it feels like it is a year ago or 2. So I'm trying to fast forward. It's not. Why? Okay, play. Stop. Okay. Let me try again. All right, so here I'm touching the aluminum and letting you see how the feeling. You see the protractor? So I hope I said it. I'm gonna watch the video again, by the way, to see if there's something missing. If there's something missing, I'm gonna write it on the results section. Probably the significant figure. This is the card. Probably you can see. And here you have a card with very fast fields, the mass of which is given to be 500. And I'm going to explain how I did the measurements so you can tell the uncertainties. And here probably I'm showing you the connections, the motion sensor. I'm sorry if my frame is not great. Probably I would learn in the coming semesters to take better videos. And here for the screen, I will put the camera closer for you to see the screen and the graphs. Okay. So you see I'm gonna explain them, XT, VT, and AT graphs. Okay, explaining each part like I did in the presentation anyway. So this is a repetition. Okay, and here I'm gonna add some masses to show you how I'm gonna take the measurement again. Probably in this video, the part about static friction is not visible. But I want you to see it. So I'm gonna fetch a video done by my colleague where she shows the static friction. It's a very simple part, but it's nice to see, all right? Otherwise, the only way for you to understand it is to read the procedure, and that's not enough. All right, so I'm gonna give you 2 videos for the experiment, one done by me and the part done by my colleague for you to see. And here you see I'm changing the height and therefore the angle of the incline, you see? Yes. So now for the chats. Okay, you're still talking about the deadline? All right, fine. So what can I say? I'm gonna say that good luck for your first lab that you're gonna submit this evening. Let me know if I can still help you. This is 1. 2, whenever I post everything, I'm gonna send you an announcement saying the folder is fully posted on Blackboard. It's gonna be tonight, the recorded session, the PowerPoint, the results, and so on. So you can start, and I'm gonna put in the announcement when the deadline is gonna be, just for us to confirm it. All right, I'm gonna stop recording now, and you can ask